Hello everybody, my name is Nikita Perestoronin. I am senior developer at DataAdvance. In this video I would like to introduce a new feature available in P7.6, direct integration with Siemens NX. NX, developed by Siemens PLM software, is a widely used solution for computer-aided design, manufacturing and engineering. The new STD NX block in P7 allows to take advantage of advanced design exploration techniques for analysis and optimization of NX models. The block can also automate exporting NX models to different exchange formats, so it can be used together with CAE integration blocks in workflows. When configuring STD-NX, you first select the NX file you want to work with. After this, the block can build the document tree. This tree contains all model parameters which can be mapped to block's input and output ports. At the runtime, the block receives values to input ports, changes model inputs like its dimensions or values of expressions, updates the model and writes outputs like model's mass properties to output ports. Optionally, you can also choose to save the updated model or export it to a specified format. Note that when building the document tree, the block actually launches NX, so it needs to know where it is installed. The path to NX can be set in block options. Let me now explain document tree contents in more detail. First of all, it includes dimensions of all model features. All user-defined expressions can also be found here. Next, the tree includes part attributes, so they can also be mapped to block ports. Finally, it contains mass properties such as mass, volume, area, center of mass and moment of inertia. The block supports both NX models and assemblies, and if you open an assembly, the document tree will contain dimensions, expressions, attributes and mass properties for every assembly component. The block can save an updated model to disk in the native PRT format and save an updated assembly to a zip file which contains the head assembly and its components. Also, the work in an NX document can be exported to data translation formats such as Parasolid.txt, IGES or STEP. The exported file can then be sent to a CAE integration block. So, the export support allows to automate data exchange between NX and CAE tools and to create optimization workflows that update a model in NX and then run an analysis in a CAE application. As P7 itself, the block is cross-platform and works with both Windows and Linux versions of Siemens NX. It's most actively tested with NX version 10, but all versions starting from 7.5 are also supported. P7.6 also includes blocks that enable integration with SolidWorks, PTC Creo, Compass 3D and CATIA V5. All these blocks have similar interface and functions. They can map model properties to ports, allowing to change and read them at the runtime, so the model can be used for optimization and other tasks. Now let us configure and solve an optimization problem in P7 using STD-NX. Consider an NX model that consists of 4 quarters of sphere with different radii. The objective is to minimize the surface area of the whole model. The radii can be varied in the same ranges. Obviously, the solution is the smallest possible sphere, that is, all 4 variables equal to minimum. This problem just serves to quickly demonstrate basic P7 integration and optimization capabilities. Creating an optimization workflow requires 2 blocks, STD-NX and STD-Optimizer. Drag and drop an NX block from the block library to the workflow and type its name. Double-click the block to open the configuration window. Switch to the Options tab and set the path to Siemens NX. Set the error handling behavior option to Output Defaults and Signal. With this setting, if the model fails to update, the block does not stop but outputs values you have assigned to its output ports. Switch back to the Configuration tab and select an NX PRT file. Click the Build Tree button. When the document tree appears, select 4 radii from Dimensions and Area from Mass Properties. Note that 5 variables have appeared in the variables list. Each of them adds a block port. As a result, 4 input ports and 1 output port have been created, which can be seen on the Ports tab. The value assigned to the area port is NAN, so NAN will be output in case when model update fails. Switch back to the Configuration tab and set the path to an export file. The model will be saved to the export PRT file in the project directory. Click OK to save changes and close the configuration window. Then add an optimizer block from the block library. Open it to define the optimization problem. Add 4 variables with bounds from 50 to 150. It's worth noting that the current model values are 70, 80, 90 and 100 mm. Then add an objective named Area. Note that Optimizer always seeks to minimize all objectives. All options are left to default, since the problem is simple and analytical, so no special tuning of the optimizer required. Save block configuration and close window. Open the links dialog and connect the outputs of optimizer to NX block inputs. Then connect optimizer's input area with the NX output of the same name. Note that in case of failure, NX will send NAN value to the optimizer. It won't lead to the optimizer failure, since optimization techniques implemented in P7 can handle such cases. The workflow is ready to launch, so at first, let's save it. Switch to the Run screen and click the Run Workflow button. Wait a little until the workflow is finished. The workflow is successfully finished. Optimization results can be seen on the Analyze screen. First, create a new report. In Project Database, expand Optimization, then Last Run and Monitoring. Drag and drop the Optimizer Optimal X record to the report to create a table with data. As expected, the solution is 50 for all variables. To see the optimization history, drag and drop variables data to report, then select all columns in the table and click two-dimensional line plot. The plot shows how values of variables were changed during optimization. Finally, view the optimal model in NX. Go to the project directory and open the export PRT file saved by std_nx block. As expected, the solution is a sphere. Thank you for watching this video. Goodbye.